Hello, in this video we will give the definition of continuous function, right continuous function, left continuous function. We will outline the properties of continuous function, and we will, given a graph, we will find out the points of continuity and points of discontinuity for a given graph. Let's start with this. Let's go ahead and define a continuous function. First, let's say f is a function and its domain is represented by D, and the range of the function is denoted by R, and we say that f is continuous at a point A. Let me adjust my screen. The point A, this A is inside the domain D if it satisfies the following properties. One is the limit is well defined at A, exists and is well defined. The second property is that the function value is well defined if A is defined as well. Then the third one is that limit should equal the function value. If these three properties are satisfied, then we say the function is continuous. If even one of them, if one is not satisfied, if the limit does not exist, then the function cannot be continuous. If the function value does not exist, then the function is not continuous at the point A. So it is important that all these three conditions are satisfied. And another point that you need to pay attention is here the continuity is defined at a point A, and A should be inside the domain. So that means usually in the previous sections we define the limit to be an open circle, so limit is always an open circle, and the function value is the solid. So limit will exist only if the open circle is equal to the solid. Once again, when we get to the graphical example, we will see greater role of that. Now, if the function is continuous at every point in the domain, is continuous at every point in the domain D, then f is continuous on the domain. F is continuous on the domain. So one big difference is the limit is always defined at a point. Limit is not defined on the set, but continuity is also defined at a point, and it could be, if it is continuous at every point, then it could be extended to the entire set. That's a big difference. And for continuity at a point means the point should be inside the domain. For limit, the point need not be inside the domain. Now let's define the right continuous. Like again, you see that f maps D to R. F is a function, is a domain of the function is D, the range of the function is R. F is right continuous at A if the following at A, and A should be inside the D, if the following conditions are satisfied. One is the right hand limit exists, x approaching A plus, f of x exists, so that means that there is an open circle. And 2 is the function is well defined. Limit x, the function is well defined means fa is defined. That means the function value is always represented by the solid. And the third one is we have limit x going to A plus f of x equals f of A. So that means we have open circle is equal to the solid, equals solid. Okay, so it's very similar to the definition of continuity, except that for the right continuous function at A, the limit is taken from the right edge. It's not at the entire point A. Now let's go ahead and define the left continuity. Again, f is a mapping from the domain D to the range R. The point A is in domain D. Then f is left continuous. F is left continuous at point A in D if one is the left hand limit exists, x approaching A minus f of x exists, and 2 is fa is defined. Then 3 is you have limit x going to A minus f of x equals fa. Now the left hand limit is an open circle, and fa is defined as a solid. Then you have open circle is equal to solid. Okay. Now these are the definitions of function being continuous at a point A, and the function being right continuous at A, and function being left continuous at A. Now let's discuss the properties of continuous functions. I mean, the same thing, the sum rule exists, like if f is continuous, or in other words, let f is continuous on domain D, and G is continuous on domain D, then we can say first the sum rule. One is that f plus g is continuous on domain D, on D. Then there is a difference rule, which is f minus g is continuous on domain D. Then there is a product rule, which is f times g is continuous on D. Then there is a quotient rule, which is f over g is continuous on domain D. I mean, we want to make sure, because division by 0 is undefined, we want to make sure that g is not equal to 0. And then there is a constant multiple rule, which means c times f is continuous on D. So these are, I mean, the sum rule, difference rule, product rule, quotient rule, and constant multiple rule. They existed for the for the concept of limit as well. They will repeat themselves again in the context of differentiation and integration. We will see that again when we get there. Now let's look at this graph here. So let's start with moving from left to right, and you can measure the domain of the function and range of the function. Now you can see that I mean, the left hand limit at -2 for the function is +2. The right hand limit for the function -2 is going to be -1. You can see that the left hand limit is not equal to the right hand limit, so the function, the limit does not exist at -2. the limit of the function does not exist at -2. However, you can see that f of -2 is going to be +2. So the the left hand limit is equal to the function value. So you can say that the function f of x is left continuous at -2. Now let's talk about 0. So we can see that the right hand limit or the left hand limit for the function at 0 is 1. The right hand limit for the function at 0 is also 1. The function value of 0 is 1. Now what can you see? I mean, the left hand limit is equal to the right hand limit, so the limit of the function at 0 is also 1. So now the limit is equal to the function value, so you can conclude by saying f of x is continuous at 0. Continuous at 0. Now here you can see that limit x going to the left hand limit for the function at the 3 is 0. The right hand limit for the function at 3 is also 0. So the limit of the function at 3 is 0. That's because the left hand limit is equal to the right hand limit, so the limit of the function is also 0. So you get f3 is -1, but the limit is not equal to the function value, so you can see that f is not continuous. Function is not continuous at what else? Function is not continuous at 3. Now one other observation that we can make is, I mean, limit does not, here the function does not have the limit, so we have at -2 you can see that no limit, no continuity. I mean, it's really bad way to say it. This is if the limit does not exist at -2, the function is not continuous at -2. That's a proper way to say it. But in other words, no limit, no continuity. Here you can see that at 0 the limit exists and limit is equal to the function value, and that's why the function is continuous. You can see that continuity guarantees limit. Continuity at 0 guarantees limit. Okay, and here you see here limit exists, but the function is not continuous at 3. So limit does not guarantee continuity. I hope it does not guarantee continuity. See, that's the difference. For limit to exist, you see, I mean, in the third case, the limit exists because left limit is equal to the right limit, but the limit is not equal to function value. That's why the function is not continuous. Here the limit is equal to the function value. That's why this is continuous. So continuity guarantees limit, but limit does not guarantee continuity. So in a way, if you look at it, I mean, if there is a big box, this is a box of limit, and continuity is a smaller box inside. So a continuity is inside the limit. So continuity guarantees limit, but limit does not guarantee continuity. Like let's say A here and a point B here. So if the function is continuous at A, there is a limit at A. But if there is a limit at B, the point B is not inside the continuity box. So continuity is not guaranteed at B. So continuity guarantees limit, but limit does not guarantee continuity. This is a big thing that you need to understand. Once again, in this lecture, we talked about the definition of right continuous, left continuous, the definition of continuous functions, and if the function is continuous at every point, it is continuous on the entire set. We also learned how continuity and limits are connected. Continuity guarantees limit, but limit does not guarantee continuity. I hope this is clear. If you have